Okay, let's do this. Let me pull up chat just so that I know that it works. Okay. So let's try Advent of Code Day 8. Let me put the link in the chat as always. This is today's challenge, and let's pin that one. So there we go. So yeah, Advent of Code Day 8. Yesterday was a bit harder than the days before, so finally getting a bit of a challenge, and I've heard today might be even more of a challenge. So let's see how we'll fare. Pull this here. Okay, Day 8, Treetop Treehouse. The expedition comes across a peculiar patch of tall trees, all planted carefully in a grid. The elves explain that a previous expedition planted these trees as a reforestation effort. Now they're curious if this could be a good location for a treehouse. First, determine whether there's enough tree cover there to keep a treehouse hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. The elves have already launched a quadcopter to generate a map with the height of each tree, your puzzle input. Okay. Each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all of the other trees between it and the edge of the trees are shorter than it. Only consider trees in the same row or column. That is, only look up, down, left, right from any given tree. All of the trees around the edge of the grid are visible, since they are already on the edge. There are no trees to block the view. In this case, that only leaves the interior 9 trees to consider. The top left 5 is visible from the left and the top. It isn't visible from the right or bottom, since other trees of height 5 are in the way. Let's see. Okay. So if there's an equal height in front of it, then you can see it. That is good. Okay. With 16 trees visible on the edge and another 5 visible in the interior, a total of 21 trees are visible in this arrangement. Considering your map, how many trees are visible from outside the grid? Okay, so that is good. So you start at the edge. Basically, if you build this as a map and you start at a -1 before it and then just look every way, that should work. Basically, you need to traverse every line and angle until you find a higher number, right? That seems too easy. Okay, let me see if I'll eat my words later. So let's build day 8. Let's see, day 8. And I need to bump up the zoom. Let me see. Hey Luke, welcome. Let's see, day 8. So, input, 2 lines. Let's select as int 32s. To array, no, to char array actually. As int 32s. To list. Okay, so this gives me a list of list of ints probably. For map is this, right? A list of ints. Okay. So we do int directions is actually let's specify the way we walk. So that is so first we do up is -1, then we do right, then we do bottom and then we do left. Actually, let me see, because we need to start. Goals is not length, count. Goals is not 0, count. Basically, we need to go from like X. Yeah, I'm just wondering, how do I traverse from each side? Let's see. Last year, this year is once again struggled with the stupid two areas. Okay. Yeah, I'm just trying to figure out in my head, since we need to approach every side. Basically, you have 4 loops that you need to do. I can write them out, but I thought that I'd do it like this. We can do that for each var direction in directions. If direction if direction dot x is null, move y, else move x. So basically, if the x doesn't move, we either go up or down, and then we just need to iterate either from front or back. So we do if direction dot y is 1, iterate up, else iterate down. So this would basically be 4, and I'm still writing it out now. So let me see if I can write this differently. Int get start x well if it's 0, we start at 0, else we do val is 1. Actually, we can do this switch val. Let me see, I need to remember the notation, because I remember that I wrote this like on day 3 or day 2. That switch, that, okay. Let's see, so it's this val switch, and then we get 0, we start at 0. One, we start at 0, minus 1, we start at goals minus 1. If I remember correctly, right? Get end x. This would be if it's at 0. What I'm trying to do is we basically need to write 2 for loops, right? Because we need to iterate every level, and then we walk in a direction. And I'm just trying to figure out, is there a way for me to generate those both loops based on these values. And I'm struggling a bit with it, so I'm going to abandon that and just write it out here. So we do, let's see, maybe I'll refactor it later, but for now it's going to take too much time. So let me just write out the code for now, because I'm getting stuck in my own head. So we do for int x is 0, x smaller calls, increment x, for int y is 0, y smaller calls plus y. Just thinking how we should track this, because okay, you know what? I'm going to do the naive way and just not worry about it for now, and worry about part 2. So for now, we'll just do int previous is -1, and then we do if map y comma x. Actually, it's first the lines, then the columns. If map is larger than previous is, let's cache this value as well. Int previous val, we set previous, we do val is this. If it's larger than previous becomes val. And we increment actually the count, visible count is 0. We increment visible count, else we break and move to the next one. Okay, so that is one direction, and then we need to do this 4 times. So what my idea was that based on this we generate this value, and then it will already say this. But for some reason I can't work it out in my head now, and I'll just do it. I'll just do it 4 times now. So yeah, let's do the same in reverse. X is calls -1, x larger equal to 0. And we decrement x. Basically, this is the same. Yes. And then we need to do the same, but then in the opposite y direction. Right. Let me see. So this is the pattern. See. This one will take 1x and walk it down. No, will already do 2 ways. Let me see. So this will, for each column, it will look down. So it should probably also do the same, but up again here. And just do the inverse here. So we have y is rows -1, larger equals 0, decrement y. So yes, rows. And we do the same here actually. So we first do that, and then we go the other way. And I think this is correct. Let me see. Console.wetline visible count. And for sure I will do the test input here, just because I'm just tripping myself up in my head right now. in here. And let's make sure that I run day 8 instead of day 7. Okay. Visible 28. Let's see what the actual answer should have been. 21. So that is not good. How is that possible though? 2, let's see, 3, so it's 20, let's see, 2, 4, 5 times 2, 4, 5. So there's only 25 in there. Wait. There's only 25. How can I get 28? Let me see. I count the corners twice. Haha, that's a good one. I count the corners twice. Right? So actually, the answer should always be visible count minus equals 4. Subtract the outer corners since they will get counted double. Okay. And then I'm still 3 too high. So let me, what could that be? Oh, because I need to track indexes, unique indexes, and not, yeah. That's a good one. Hash set int x, int y, int y, x, visible indexes. Okay. Let's see if not visible indexes. Let's also write this as a pairing now. Actually, I could do this as a dictionary, and then we have the rows and columns actually int visible map is this. Okay. Func int. No, it's actually action. Now I can return a bool. Mark visible xy. Target value x out and current count. Current is 0. And then we do a visible map. Y is current count plus 1. Something like that. Bool result. No, actually, that is not true. This is a 2-level. This could be a hash set of int hash set. But, I noticed that I still need to wake up a bit. I'm sorry. Out var visible columns. Okay. If visible columns contains contains x, add x, right? Return false. True. You can also do already mapped. We can do if not already mapped, and then return already mapped. Okay. So now we can do if mark visible x, y. Did I do this in the right order here? Yeah, I did x, y here, okay. That should be good. And then I need to do that on all these places. This no longer is needed, and now I should have the actual answer. 0, cool. Let me see. Oh yeah, I need to add it actually. Add y, comma, visible columns. Okay, let's try that again. 14, close, but no cigar. Let's see. I need to do the inverse actually. Wait. Let me think. Right, so now we have in this visible map, we have 0, 0. We need to make this, yeah, we need to return the inverse. If it's a new one, sure. Wait, what happened here? Okay, let me check this code and write it out. Bool bigger. Anyone solving in Python? Hey Shanti and Smap UK. I misread the definition of visible. I made it too complicated to start. I'm reading it part 2 and repeated my mistake. Okay. Yeah, I'm already struggling here, so that's good. Let's see. Bigger is that. If bigger. Actually, I'm doing the inverse. I should be checking the inverse here, right? Let me see. No, if the next tree is bigger than the previous, then it's visible. So that is good. Console, that right now. iOS. Let me just write out the indexes that it says that are bigger, then I can debug all my crap. Let's compare this to the input. Let's see. So it does this one. Let me see. My code, the first set of codes goes from, oh yeah, I do the X column first. And then I go down. So, but basically that should mean that I do, let me see. With this logic, like the first set of values should always happen there, right? Because it does first does row 0, column 1, column 0, then it does row 1, column 0, and that one should already be visible. So it's really, let me just walk through it. Let's see. So this is 3. Oh, I'm an idiot, because when I break, I need to set previous back to -1. That's my problem. Okay, let me see. Still 14. What the? That is strange. What? Nee. Let me see. I have a whole feeling that you've done exactly what I did. Let me just walk through it, because let me see. This one is good. Then mark visible, add it. Okay. So let me see. So now it's checking this one, and that is true. None of these going top to bottom, only this one should be marked. So that is good. Okay. Oh wait. Oh yeah, I then checked from the other end. That's what tripping me up. Okay, that's good. So I didn't need to have this one here, because it will already do that. And I need to do no, I actually need to break. That's good. So basically that one wasn't needed. Okay, let's go on. So now we have the bottom value. So the same column looking from the bottom up is 3. That is fine. And the next one is also not good. So that is good. So now we check top, down, and bottom up. And then we do the next row. Let's see. So that is good. So it adds that one. And then it's not good anymore, and it goes back. Okay, and so also I didn't need those those resets here, because that happens automatically. Let's see. Okay, so now we have x is 1, and we should add the outer value, so that is good. So then we say, okay, this one, now it checked the second one from here, so that is good. So it wrote down 0, 1, so that is good. It should also do this one, and then it needs to stop. Ah, but that is not true. I just need to keep going the entire line, because there might be a bigger one later. Yeah, okay. I think I've found out what I've done wrong. But I always need to set the previous here. So that was my mistake. I need to always set previous and just keep going. Yes. Because there might be a bigger tree further that you can see. That's why it's really nice to have a sample input that you can struggle with. So let's see, if I run this now, what does my output say? Is it finally 21? No, it's 18. Okay, getting closer. I should probably draw this in a grid now. So yeah, we do for I is for int x is 0, x smaller than equals increment x. Do the same for y. Rows increment y. Actually, I need to swap these. We'll just print out what we have right now. Let me. And let's see, black square character. Cool. So let's see if let's see if visible map target value y var out var visible goals else. Come on. Goals. Let's see, and now we have this. Visible goals, lanes X. Okay, so let's run this. So now I have a map of what we think is visible. So as you can see here, there are gaps in the outside lines for some reason. So that's 1, 2, 3, 4. That should give me 22. That's interesting. Do I still have a break in my code? Let me see. The previous. Should have probably written it the other way around so that I can see them all. Let's see. Basically, every index that has a 0 on one end or a 4 on one end should be there, but it's not. So I'm curious about that. Let me see. Am I missing something still here? Let's see if Mars is on this Friday. Let me see. Oh Jesus! I'm trying to use this website to copy a character, but it's it's horrible. Let me just see if I can put it in here, because I just wanted this one. That probably makes it a bit more readable. That has question marks. Great. Let's see. So basically, if you go to x0y1, Let me see. I needed to flip these actually. Let me see. So first we do the X-based ones. Let me see. I go. So I go from left to right, and I check top and bottom. Then I go from right to left, and I also do top to bottom. That should be everything, right? No, this is stupid. My second loop is wrong because I need to invert these. Ah. And then I need to do the X loop here. I'm making a mess of this. Let's see, so X up and down. Did I throw that one away? No. I'll just write it again. Let me see, so this is basically for int X is equals -1, X larger equal 0, minus X. Right, so first we have one up, then down. I already wrote it like this here, so this one becomes 0, smaller than equals plus. Basically, it needs to be the same here. Let me see. I only need to do that once, right? What, did I throw away something? Yes. Let's see if it's if I make sense of it now. Okay, so now it says 22 and it's one too many. And now we need to figure out what it is. Let me see. Let me see. A tree is visible if all of the other trees between it and the edge of the grid are shorter than it. Okay. Wait. A tree is visible if all of the other trees between it are shorter than it. Yes. I've checked that. Only consider trees in the same row or column. That is, only look up there. All of the trees around the edge of the grid are visible. Yes. So they say this one is visible. But does it need to have two? Let's see. Only from the right. No, okay. The center 3 is not visible from any direction. It's weird because this one should be visible from the left here. Let me see. That's interesting. This one shouldn't be visible from anywhere because that's a 1. So let me see, if I do this by hand and look at it, this one can't be visible. This one can't be visible. Yeah, I noticed my bug now. Because this needs not to be previous, but the maximum value actually. Huh, okay, figured it out. So let's make this biggest. Math.max. Okay, so this will, this was the bug that I have there. Now can I get the correct answer, please? 21, yay, okay, Jesus Christ. How many bugs can you write in something so simple? Okay, that was horrible, sorry guys. Let's pick out this one. Oh yeah, and now we have a full forest map, yay. Did you like the map? Okay. Let's see if this is correct. Woohoo! Got there in the end. Jesus Christ. Continue to part 2. Content with the amount of tree cover available, the elves just need to know the best spot to build their tree house. That will, they would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up. Yes, stop if you reach the edge. It's the same or taller than the tree under consideration. Stop if you reach an edge or at the first tree that is the same height or taller than the tree under consideration. Okay, if a tree is right to the edge, at least one of its viewing distances will be 0. The elves don't care about distant trees taller than those found by the rules above. The proposed treehouse has large eaves to keep it dry, okay? Shouldn't that be leaves? But I'll look that later. So they wouldn't be able to see higher than the treehouse anyway. Let's see. In the example above, consider the middle 5 in the second row. Looking up, its view is not blocked. It can see one tree. Looking left, its view is blocked immediately. It can see only one tree of height 5 right next to it. Looking right, its view is not blocked. It can see 2 trees. Looking down, its view is blocked eventually, so it can see 2 trees. One of height 3, then height 5. Okay. Blocked immediately, you can see only one tree. Okay. A tree's scenic score is found by multiplying together its viewing distance in each of the 4 directions. For this tree, this is 4, found by multiplying 1 times 1 times 2 times 2. Okay, however, you can do even better. Consider the tree of height 5 in the middle of the 4th row. So you're looking up, 2 trees. Looking left, its view is not blocked. You can see 1 tree. Let's see. Looking right, the view is blocked by 2 trees. Master tree at height 9. Okay. So ideal spot for the treehouse. Consider each tree in your map. What is the highest scenic score possible for any tree? Okay, this is interesting. Because it said something that it needs to stop once you reach the edge of first it is the same height or taller than the tree under consideration. At the first, yeah, okay. Ah yeah, because that's the upper limit. The only thing is that because you need to do multiplication on what you see, that normally there's like a pathfinding algorithm, right? And you stop when you go below the best score that you already have. But in this case, I wonder if you need to map out the entire field. And the annoying part here is that I didn't write a function to explore it, right? Because I hard-coded it. As I said, I wanted to do it this way, and I will have to do that now for the walking in each direction based off a given point. Yes. Okay. Let's start again with this. Let's start at part 2. Let's see. And let's go back to the test input just to be sure. So now we basically need to go. I'll just write the naive approach once again. I know it's not optimal, but my brain isn't functioning as I want it right now. Is 0x smaller than goals increment x. It's y is 0, y smaller than rows increment y. Get visible scenic score, right? So we do a func int. Let's just make it int y int x, and it returns a int for a score. Like this. The int score is 0, return score. Actually, it's list int scores is new. Let's do that. Score is scores. That's probably a better way, but as I said, I'm just gonna do it simple right now. Really simple to me. And then we need to go for each directions. We also have max file is map y no block.y block.x. So this is our max file, and current max as well. We can do actually we can do this. And we do local score let's see. I have somebody here in the office. So if you hear somebody in the background, that's why. Let me see. Local score is 0. Current max is max val. And now we need to walk each direction. We probably also need an xy. Local x, local y. Local x is loc x, local y is y, while local x larger or equal to 0 and local x smaller than cos, and local y larger or equal to 0 and local y larger than rows. Then we do this, and then we do local x plus is diff x, local y plus is diff y. So this will move from to every direction from the place where we are. And then we do scores dot add. And now I need to know if it's there are two edge cases here, because if you're right at the edge, we don't get an extra view, but if we're like this one and it looks to the left, it immediately encounters something that's of the same height and it stops. So then it will be 1. So if we're at the edge and we don't have a score, it's 0. But if we're not at the edge and we don't get something that's smaller, we get a 1. So that's also an edge case to consider here. So now we need to do if loc.x is 0. Let's see, no, if score local score is 0. Found nothing, right? Found nothing. If this is the case, if local x is 0, no, if starting point of x is 0, or loc y is 0, or loc x is cos minus 1, or loc y is rows minus 1, score stays 0, else local score gets 1. Right, so that is it. Let's see, because there was an example, was there an example where one next to it is bigger right away? No. Let's see. That's too bad. There's no example where the adjacent one is immediately bigger. Let's see. Looking left, if view is blocked immediately, it can only see one tree of height 5 right next. Okay, so even if it's fully blocked, it at least can see that tree, so that will count. And I think that's the case. If not, this might cause an issue. But we'll see. So now we always first need to move before, yes, we first need to move and then we need to check. So we always need to start here. To make sure that we don't go off the map, then we need to check if map local y map local x. So we do val is this. Oh, come on. Val is map. Okay, let's keep a local version of that as well. Val. So if val smaller than current max. Actually, we don't need to keep the current max because we need to stop at the first one that blocks, right? No, no. It needs to be smaller than current max. Yeah, it always needs to go down. As soon as one is bigger, it stops, right? Let me read it again. Dun, 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 dun. She was blocked me down. Blocked eventually. You can see 2 trees. One of height 3, then the tree of height 5 that blocks it. Okay, so the blocking one needs to count anyways. Okay. So basically, once you see one that's bigger, let me think about this. Because if there's multiple, you need to stack that there as well. So let's see. No, it will still need to be it will be the same logic as before. It just has an upper cap. Let's see. If val is larger than current max, and yes, that is good. Then we do current max is val. And we count a tree, plus local score. We do this current score, current max smaller than max val. Okay. So this one needs to be below the value that we check. Then we do this, we look at the value. If it's bigger than what we've seen before, we count it. So that also means that we don't need to do this at all. So if it's bigger than what we've seen before, we count 1. Otherwise we don't. And once we hit the max, we stop. I think that should be it actually. Let's see. So this is get scenic score. Console that right line. Score. Map score. This is get scenic score. We do y, x, like that. Let's just print it out. X, map score, 2, 2, 2. Console, right line, biggest. Let's see if this works. I should probably remove this so that it doesn't print out the entire map, as well as all these print lines. So let's see. Biggest 0. Okay, that's great. Okay, let's debug that. Okay, so we have max val is 3. Okay, so this will be the top. Let's see. Oh, I never add the score. Never mind. right? Yes, I never add the scores. If local score larger than 0, scores that add local score. Okay. Let's see if this does something. Biggest 4, and we have that a few times, but that shouldn't be the case because there was one that was bigger, that was 8. So let's see. Let's see, there's 1 there, 1 there, 2 there, 2 there. Okay. So this is 0, 1, 2, 3, 3,2. Okay. Let's debug that one. If y is 3 and x is 2, system diagnostic debugger. Great. Okay. Let's check this out. Max val is 5. Okay. So we start off looking at, we look up, okay? So basically it should get 2 values up, 2 to the right, 1 down, and 1 to the left. Let's see. Okay, so local score gets added. That is 3. Next value is 5. It gets added. Okay, local score is 2. Great. So now we look in which direction? To the right. Okay. Value is 4. That is fine. Next one is 9, is also good. So a 2 gets added, okay? What direction is this? This is looking down. Let's see. Looking down, it should have only 1. Okay. So it's probably the one to the left and that doesn't work as expected. Let's see. So this one is 3. Okay. Wait, what? Oh yeah. Okay, let me see. So to the left is 1, there is 2, there is 2, there's only 1. Wait. 2, 2, looking to the right is view. Yes. So which one didn't work correctly? Let me see. Because I have 2, 2, 1, 1. Okay. Let's do that again. Sorry. Yeah, this looks up. Okay. It sees the 3. Okay. So once again, it should, like, I do the same way, right? Up. Wait, it says left, it's not blocked, it can see two trees. So the same height. Wait, let me read it again. To measure the viewing distance, you can look up, down, left, right. Stop if you reach an edge of the first tree that is the same height or taller than the tree under your consideration. If a tree is right on the edge, else don't care about distance tree taller than those found by the rules above. Okay. So basically, if the one after it is the same height, it will also count. As long as it's not bigger. Okay. Stop if you reach an edge that is the same height or taller than your tree. If a tree is right on the edge, at least one of its viewing distance will be 0. Don't care about distant trees taller than those found by the rules above. Ah, yeah. Else don't care about distant trees taller than those above. The proposed zeros has longer eaves to keep it dry, so we'll be able to see the height. Okay, so basically I'm stupid because it just needs to keep going until it gets a bigger one. Yeah, okay, I'm stupid. So the rule is not just, it basically just needs to do this. So I just need to remove these lines. Basically it should say, while val is smaller than this. Val is 0. Or -1, it doesn't really matter. Right. Let's run this again. Definitely wrong. Damn. Because now my code says... Let's see. And now I need to remember if I need to print X, did I print XY or YX? Okay, so row and then column. So basically my code here for row 2, so 0, 1, 2, column 0, it says, oh yeah, 1, 2, 3, 4, wait. So basically it has 1, 2, 3, 4 here. 4. Okay, so they didn't just give the biggest example, so that doesn't mean it's wrong. Which one is 8 actually? Do I have that one? 3, 2, 0, 1, 2, 3, 2. Oh yeah, okay. I actually have the value that they say, but that's just not the biggest one. Let's see. This tree seen account. Ah, that's not true because everything on the corner will have a 0. Ha. So I need to actually just skip every edge case here. Because basically this case so if I run it again now, reading is difficult. Okay, so now it will give the biggest as 8 because every edge case will have a 0 because it's on the edge, and since it's times, all the ones on the edge don't count. Jesus. Oh, this was horrible to code. Not to code. It's not horrible. I'm just very bad at not messing this up. Okay, that's a fun challenge though. It gets fun once you figured out all the stuff that you didn't read or do correctly. Oh yeah. So the biggest one is this one. What's the highest score possible? That would be this. Woohoo! Gold star. Okay. Jesus. Oh, that's a lot of debugging today. But this also shows how important it is to have good debugging skills, because yeah, that's just the most important, to find out, to be able to find out what's wrong and why. Whew. I did understand the edge case exclusion though. Yeah. So you were better than me yet again. It's always good to just get it right in the end, but Jesus, this wasn't an easy one. It was easy if you read everything correctly. I'm now really curious to see how the people that do this really fast actually solve this. Basically, like the thing that I wrote here, just the walking logic, that's what I wanted to do for the first part as well, instead of hard coding it. And there were so many mistakes in coding today's challenge. I wish I wasn't as busy as I am, because I really want to now refactor this and clean it up. My refactored version is in the Discord. Okay, let's take a quick peek at that. So let's see. By the way, for the people, if you want to share, the Discord and Telegram links are in the video description. Let me see, solution 1 is visible, okay. Let's see. It's just, yeah, like this is basically what I wanted to code, but my head just couldn't do it while streaming. Let's see. Is visible in direction? Yes. Yeah, basically the edge detection, viewing distance. Here. Let's see. Yeah. Yeah, it's basically the same logic. My original version had 4 loops, he says. Yes. Yeah. Like I said, I really want to refactor the code, and it would probably be something like this. Yeah. It's just really a struggle today to just code it right the first time. But yeah. But usually, even when I struggle during these days, afterwards I'm happy that I did it, and I like the challenge. But when you're in the weeds and you have to figure out why stuff isn't clicking, that isn't the best. But it's really nice that there are good examples in the code that at least let you know when you do stuff wrong. So yeah, thanks yet again for seeing me struggle today, and let's hope to